Hello everyone. In this lesson we will look at decoding strategies in text generation. So this will span over two videos. This is part 1. Here we will look at the main concepts, and in part 2 we will look at the code examples, and we will give a demo of these concepts. So first of all, what are decoding strategies? So these are the methods that are used to generate text sequences from language models. So remember that when we talked about GPT-2, these kind of models are trained on kind of autoregressive fashion. So we give some words, word 1, word 2, word 3, and the goal of model is to predict what will come next, that is word 4. So it's trained in this fashion. It's called autoregressive. So there are different strategies for picking the next word, and these are called decoding strategies. So these ensure that the generated text is coherent, diverse, and contextually appropriate. So this W4 should be coherent and not some random word. So there are many challenges like balancing randomness versus coherence. So if you keep it very less random, so you will get the same kind of word being generated. So after word 4, word 5, let's say again some word, next most probable word is W2, then again it will keep repeating W3, W4, W5 and again W2 until you reach the maximum number of tokens. So you need to insert some randomness, but if you insert too much of randomness, then you may lose coherence in the text. So you need to keep a balance between these two. So the first approach is greedy search. So in greedy search, first of all we look at the most likely word at each step. So as we discussed, like if we have W1, W2, W3 and the next probable word, so what the model will do, it's that given these three words, it will try to find the probability of all the words in the all the tokens in the vocabulary for this particular whatever model we are training. So let's say it has 50,000 tokens starting from 0. Then first token has a probability of, let's say, 0.00001. Second has some more probability, let's say 10,000 word has a probability of 0.02 and so on. So for all the words in the vocabulary, it predicts, it gives some probability, and whichever is the highest probability, that word comes here. Let's say W10k comes at the place of W4. So this is a greedy approach. So we repeat until a stop token is reached, or we exhaust the maximum number of tokens. So one benefit is that it's very simple. It's very natural that you have 50,000 probabilities and you pick the highest probability. So this is simple, this is fast, but it may lead to repetitive and suboptimal text. So as we discussed, like let's say we have a text like, it was a fine sunny, and then we want the model to complete the rest. So maybe it predicts fine sunny morning in India. I took breakfast in the morning, and let's say it got morning, and then again it starts to repeat the same most probable token. So you may feel some repetition here. So what should be a better approach? So there is something called beam search. So it explores multiple possible continuations simultaneously. So let's say we have a word, the, and there are three possibilities: the cat, the dog, the tiger or something. So let's keep it to 3 only at each step. So it has a probability of, let's say, 0.5, 0.4, 0.1. Again, 3 words following cat, maybe meows, eats, runs. Similarly, for dog there are 3 actions, for tiger there are 3 actions. So in greedy approach, what you were doing, you were picking, so given you will pick cat because it has the highest probability, and then you will pick one of the branches, one of the words which has highest probability, and so on. So in beam search, you will do the same for number of beams. So you define number of beams, let's say n is 3, and let's say there are more words, but let's say if number of beams is 3, then you will pick the 3 most probable words at every step, and then ultimately you will return the branch that gives maximum probability. So like here in the first step, if you take this branch, and let's say it was 0.1, 0.4, and there are a few more branches. So here it's 0.5 multiplied by 0.3. You can have more branches. So it's 0.15. This branch has 0.4, but let's say one of the branches is 0.8, one of the words. So although in the greedy you would have picked this one, the cat something, here the second most probable is 0.4, but later we get a word which is of probability 0.8. So you get 0.4 multiplied by 0.8 is 0.32. Similarly for third one, if the number of beams is 3, you will keep track of 3 beams. So you see that 0.15 is not the highest. We have a better probability for this path, 0.32. So we will pick the dog, maybe this 0.8 was barks, and this has a probability of 0.32 instead of picking the cat, meows, which only gives a probability of 0.15, although the greedy approach would have picked this one. So this is slightly better than greedy, and it does not incur repetitions like greedy. But as you can see here, we are keeping track of 3 beams in parallel, whereas in greedy we were only picking one word. So this is computationally intensive, and it's slower than greedy. So it finds the most likely sequence which might have been missed by the greedy, but it's expensive computationally and may produce repetitive results still. So let's see some other approaches. So we have sampling strategies. So in greedy and beam search, we were picking the most probable words. In sampling strategies, what we do, let's say we have word 1 with a probability of 0.3, word 2, or let's write in percentage, it has a probability of 10%, equivalent to probability of 0.1. W2 has a probability of 30%. W3 has a probability of, let's say, 50%. And let's say W4 has a probability of 10%. So instead of always picking W3 or W4 or W2, we will sample it in such a way that the probability of picking W1 would be 10%, equal to their probability of occurrence. So these probabilities are denoting which is the most likely word after a given set of words. So we have some words and we are trying to predict at this position. So we are talking about this position. So these are the most probable words. So a W1 is likely to occur with a probability of 0.1. So in sampling, we will pick these words in probability equal to their other probability. So this probability is denoting what is the most likely word as predicted by the model. But while picking also, we will make them as likely to be picked. So let's modify the greedy. So if we take the plain greedy, we will always pick this W3. But if we modify the greedy and say that pick these words with a probability equal to their likelihood of being the next word. So if we pick among these four, in greedy we will pick, if we do sampling 4 times, we will pick W3, again W3, again W3, again W3. It's always certain we will pick always the highest. But if we use this probability instead, then we will pick, we are likely to pick W3 2 times because it has 50% probability of being picked, and W2 with a probability of 0.3. So two more times we will pick some other. So I might have confused, but this probability denotes the probability calculated by the model for which word is most likely. And while picking, instead of just seeing the probability and picking the highest one, just sample them and pick them in such a way that W3 has a probability of being picked 50% of the time, W2 has a probability of being picked 30% of the time, and so on. So similar to this idea, we have multiple sampling strategies. So one of them is random sampling. So it adds randomness by sampling from the probability distribution. So just randomly pick one of these. Then we have top K sampling, where we consider the top K most likely tokens. So we pick, let's say K is 3. So we see that which 3 words has the highest probability in the vocabulary. So we pick those 3 words, and from there we will pick in this fashion. So whatever is the probability, pick in that ratio. Next we have top P sampling, very similar to top K sampling, but instead of a fixed number of words, we start by thresholding on cumulative probability. Like let's say this top P, so P value is let's say 0.9, and let's say most probable word is WA, which is 0.3. So it's less than 0.9. So we look at next probable word, let's say WB, let's say it's 0.25. Now what is the cumulative? It's 0.55, still less than 0.9. So we go to next probable word WC, let's say 0.2, still 0.75, and then WD maybe 0.15. Now its cumulative for these 4 is 0.9, and we have reached our P. So we will stop here. So we don't know beforehand how many words we will sample from. So in this case 4, until this P threshold is reached. So this is another sampling approach. So once we get these words, we pick them in the same with the same probability. Like if it's 0.3, then WA has a chance of 30% chance of getting picked. WB has a 25% chance of getting picked, and so on. Next, there is a parameter called temperature. So it adjusts the probability distribution by making it sharper. So one thing to note here is that, let's come here. So we have picked 4 words, or let's say in this case 3 words only. So these words may have, let's say, 0.3, W2 has 0.25, W3 has 0.2. So only 3 words since K is 3. But if you sum the probabilities, it's 0.3, 0.75. So what we do once we have the candidates, we do take something like softmax. So let's say EPI denoted by divided by sum of EPIs, or better J, Pj's. So here J will be from 1 to 3, and Pi will be corresponding to each. So this 0.3 will increase. You see that we have only 0.75, but we will scale them in such a fashion using this softmax, such that total probability is 1, because these are the only 3 words, and we will pick one of these. So by certainty we will pick either W1, W2 or W3. So their probability should sum to 1. So probability of P1 will become E.3 divided by E.3 plus E.25 plus E.2. Similarly, P2 will become E.25 divided by the same value. This denominator will remain same. So now if you similarly P3. So if you sum P1, P2, P3, it will get 1. So what temperature does is that it adjusts the probability distribution by making it sharper or flatter. So let's say it was like this. So this was for W1. Let's say this is W2 and W3. So if temperature is greater than 1, then it will introduce high randomness, and it will flatten the distribution. And if it's less than 1, 0 to 1, it will reduce the randomness, and if it's equal to 0, it will become same as greedy. So you will pick the highest probability. So how it works mathematically is that we said that we picked, let's say, 3 words, W1, W2, W3, with probabilities, some initial probability, let's say 0.3, 0.25, 0.2. So if temperature is not used, we calculated that P1 was e raised to the power 0.3 divided by E.3 plus E.25 plus E.2. But so if we have a temperature T, then P1 will be calculated like e raised to the power of 0.3 divided by T, and it will be divided to all the logits. So instead of these probabilities, we will whatever is the logit we divide by. So in general we can write like Pi equal to E logit I divided by T, then sum over J e raised to the power logit of J divided by T. So in this case E.3 by T plus E.25 by T, and so on. So you see that if T is large, then it will flatten it, and vice versa. So temperature also plays a role in sampling. So if you make a temperature very high, let's say 3 or 4, then you will start seeing some gibberish text. So it increases randomness. If you make temperature to 0, you will get repetition like greedy. So I hope it's clear. In the next lesson, we will look at the example codes where we will generate texts, and we will use all some of these sampling techniques. We will also see greedy, beam search, and then top K and top N, and we will also try to adjust temperature. So one more thing is that what the model does is that if you write W1, W2, W3, So for each word, it will pick what is the next most probable word for each of these words. So let's say here the most probable word picked was W4. Now it will again give this new sequence to the model LLM, and it will take this new sequence where the just predicted word was appended, and based on this it will predict the next word, let's say W5. And now so each time it's calling the forward pass, or whatever model we define, it's calling that model, and then whatever is the prompt here. So initial prompt had just 3 words. Now in the next forward pass we have this text is modified to 4 words, and in the next forward pass again 5 words, and so on. So while we were talking about this greedy beam search and these things, we were just talking about this one prediction, like which word we should pick. But if you see the complete flow, it happens like this. For every token, a new forward pass is called. So let's see example code in next lesson.